Albert Einstein, the man who changed the universe. Hello, everyone. Welcome to the 10Voice podcast. Today, we will travel back to the 20th century to meet a scientist whose name became a symbol of the word genius. A man who taught humanity to see the universe in a new way. His name is Albert Einstein. The things Einstein discovered are part of our daily lives. When you use GPS, you are using the theory of relativity. When you take a selfie, you are using the photoelectric effect. When you switch on lights powered by a nuclear plant, you are using the equation E equals mc squared. When you stream movies online or shop on the internet, you are using quantum physics. And when a patient receives radiation therapy for cancer, they are benefiting from Einstein's ideas. Einstein is not only in history books, he is in your pocket, in your home, and in our hospitals every single day. Part 1. General information. Einstein was born on March 14, 1879 in Ulm, Germany. He died on April 18, 1955 in Princeton, United States at the age of 76. He was Jewish and had to escape Nazi persecution before settling in America. As a child, he was not the top student in every subject, but he loved thinking and imagining. The first sparks of science came from a compass his father gave him at the age of 5, and later from a mathematics book he read as a teenager. Part 2. List of major works. Before diving into details, here are the main works of his life. 1. The photoelectric effect, which showed that light can knock electrons out of metal. 2. Brownian motion, which explained the random movement of tiny particles in a liquid. 3. The special theory of relativity, which proved space and time are not absolute. 4. The equation E equals mc squared, which showed that mass and energy are the same thing. 5. The general theory of relativity, which explained gravity as the curvature of spacetime. 6. Contributions to quantum theory, including debates about uncertainty. 7. Work in cosmology, which explored the structure of the universe. 8. The unified field theory, which attempted to describe all forces of nature in one framework. Part 3. Works and explanations. Work 1. The photoelectric effect. Scientists once believed light was only a wave, but experiments showed that shining light on metal could eject electrons. The strange part was that no matter how bright red light was, it did not work, while even faint blue light could. Einstein explained that light comes in tiny packets of energy called photons. Each photon has energy depending on its color. Blue photons have enough to free electrons, while red photons do not. Think of photons as balls hitting marbles. Ping pong balls, like red light, will never move the marble. Golf balls like blue light can move it with just a few throws. This idea transformed physics and became a foundation of quantum theory. Today, it is the basis of solar panels, digital cameras, and automatic doors. Work 2. Brownian motion. Robert Brown observed pollen grains moving randomly in still water. People thought maybe the pollen was alive, but dust particles behaved the same way. Einstein explained that invisible water molecules were colliding with the particles. This proved that atoms and molecules are real. Imagine a table filled with countless invisible balls bouncing everywhere. A glass marble in the middle will jiggle because of constant hits. That is Brownian motion. This discovery strengthened modern physics and chemistry and supported industries like medicine and materials science. Work 3, Special Relativity, 1905. This theory showed that space and time depend on motion and perspective. Imagine you stand by a railway track. A train speeds by. A person on the train and a person on the ground measure time and distance differently. The famous twin paradox explains it. One twin travels in a spaceship near the speed of light for 10 years. When returning, they find the twin on Earth has aged 50 years. Time passed more slowly for the traveling twin. This is time dilation. From this came the equation E equals mc squared, which tells us that mass and energy are interchangeable. In daily life, this explains nuclear energy and makes GPS accurate. Work 4, General Relativity, 1915. This theory showed that gravity is not an invisible pull, but the bending of space-time caused by mass. Picture a stretched sheet with a bowling ball in the middle. The sheet dips. A marble nearby spirals around the dip. Earth orbits the sun for the same reason. Proof came during the solar eclipse of 1919, when starlight was observed to bend near the sun, exactly as Einstein predicted. This made him famous worldwide. The theory also predicts black holes, explains an expanding universe, and is essential for GPS technology. Work 5e equals mc squared. This equation means even a tiny bit of mass can release enormous energy. A piece of metal as small as a grain of rice, if fully converted, could power an entire city for days. This is the principle behind nuclear power plants and also nuclear weapons. Work 6, Quantum Mechanics. Einstein contributed to its foundation, but he disliked the idea of chance ruling the universe. He once said, "God does not play dice," meaning he believed deeper laws must exist beneath apparent randomness. Work 7, Cosmology. He proposed the cosmological constant to keep the universe static. When expansion was discovered, he called it his greatest blunder. Yet today, scientists link a similar idea to dark energy. Work 8, Unified Field Theory. Late in life, he tried to unify all forces, gravity, electromagnetism, and nuclear forces in one equation. He did not succeed, but his dream inspired today's search for a theory of everything. Part 4, Role in Society and the World. In 1933, Einstein fled Nazi Germany and moved to the United States. He worked at Princeton until his death. He did not build the atomic bomb, but his warning letter to President Roosevelt about Germany's nuclear potential helped trigger the Manhattan Project. After the war, he regretted this and became a strong voice for peace and nuclear disarmament. Part 5, Legacy and Inspiration. Einstein's ideas surround us today. GPS relies on relativity. Solar panels and digital cameras rely on the photoelectric effect. Nuclear power comes from E equals mc squared. Beyond technology, the very name Einstein became a symbol of genius. He once said, "Imagination is more important than knowledge." And also, life is like riding a bicycle. To keep your balance, you must keep moving. Closing. This was the story of the man who changed the way we look at the universe, Albert Einstein. Thank you for listening to the 10 Voice podcast. See you again in the next episode.